Ethereum went live, so I was working on test nets, building up miners, stuff like that. Just waiting to move into the Web3 space. Really keen to sort of hack on decentralization for real. I was part of the DAO, part of the DAO community, and from the DAO, from the community's view of the DAO, the people that were really in the thick of it, it was obvious that the DAO was limited. It was limited purposely, and there's a group of us who are actually trying to sort of work out, okay, how can we sort of extend that? How can we do a DAO 2.0 kind of thing? How can we modularize it? How can we customize governance modules, stuff like that? How can we better manage resource streams and projects? And so what I started working on was a contract stack or a contract framework to manage modular contract organizations. And some 3 years later, I'm still hacking away at it, and you know, really running into some pretty hard limits of what you can do alone in some isolated place, which is kind of where I live, isolated from any developer community. So what have I got? I've got a stack of contracts where I start from an API I call the withdrawable API, because most of these contracts are shuffling value, right, whether it be Ethereum or token. What I was running into was contract-to-contract payment transfers are not as trivial as you would think it would be. Generally use the principle of pull payments rather than push payments, where instead of like putting money in a contract and having the contract go through a list of recipients in the same transaction and pushing out all the funds, we put that onus of fund collection on the member or the account to actually be aware of that there being funds there that they can pull out themselves. So that's the pull payments paradigm. I've extended that to an inter-contract withdrawal paradigm where the contract might not actually know that there's money owing to it. It's generally ignorant of all other contracts. So what we have is a contract that I call Yank, which is a payments aggregator contract. And excuse me while I just rip through my slides. So here we have a whole bunch of sort of loosely integrated or interconnected contracts with value chains. What the withdrawable API does is it makes the assumption that the contract is smart enough to know where the money has to go. Right? So it should not matter who calls withdrawal. The contract has the custody and it should know where that money should go. So anyone can come along, and in this case I use a contract called Yank. You pass Yank an array of contract addresses, and you pass Yank an equal length array of accounts within those addresses. Right? And it'll go through, it'll iterate through that array, and if you've ordered it properly, if you've pre-discovered your value chains, it will iterate over those arrays and say, withdraw from this one, withdraw from that one. They end up pulling it into here. Then it goes, withdraw from that one. And then you can sort of like pull all your funds through a whole chain. So I start from that principle on the stack.
Excuse me. I think we can obtain more clarity if you name the actors. So I know that you mean that through a chain of events, money can be withdrawn. But let's say who, like who wants to withdraw? Why it's a little confusing.
Okay, so So a recipient could be a contract or it could be an external account. Right? So it could be a real person or it could be some other contract that owns a subcontract.
Let's say I'm running an electronics store.
Yes.
And I may need to withdraw money from customer's account because they purchased the laptop.
Mm-hmm. Well, it's up to them to pay you, but this is sort of like just sort of a base layer of the stack that I'm building up, and up here I actually have my sort of payments channels and my payments tooling, my accounting tooling, right? And I'll get into that, but so the other base layer that we have is what I call reg base, and this is a parent contract that is required for your contract or your utility to be compliant with this framework. So it requires that your contract has a reg name. It requires that your contract has an owner. There's a resource field there, which is just a 32-bit hash that you can just like use as a pointer or a small string or something like that. Some hint for a user to actually go out and find more details about the contract. We use that and we build registrars. So registrars are a triple key lookup registry. So you can look up by a contract name, you can look up by a contract address, and you can look up by a contract index. And using the index, you can iterate over an entire registry of contracts and discover what's actually in there. And these are all just mappings internally, but and I found that was the most gas efficient way of doing it rather than trying to iterate over arrays. And you don't lose your state if you need to deregister or delete state. It's a quick and easy way to actually keep track of your contracts. We partner up that with this notion of factories. Right? A factory is an API that wraps around or that carries the bytecode of what I call a product contract. So you write your product contract and you write your factory, which is just a short bit of code. Right? In that factory you have a create function, and that just spits out a product, right? Gives you back an address, and that's your product contract. A factory owner can set a price on that factory, so people come along, they actually have to pay a price for that product. So combining factories and registrars, you've got this sort of discoverable contract mechanisms. You've essentially got a DApp store. So we can extend that DApp store, and we can actually put on what I call the actual Sandal-Straps kernel layer. And this is more of an organizational structure, so you can start to begin to organize all your contracts that you're creating, and build up an organization of different functional modules. So inside Sandal-Straps we have a parent meta registrar, and it's the suitcase that you pack to migrate through upgrade processes. Right? So if this kernel contract needs to be upgraded, we can just change the owner of our meta registrar to the new kernel contract, and it will become an owner, or it will become subordinate to that.
Darryl, will you show us also a little bit of the work that you've done thinking about front end and like?
Yeah, I'll get into that. How much time have I got?
Just mindful of the time. We have about 10, 15 minutes.
Okay. So then we have like fully discoverable, organized contracts system. Right. On top of that, we can start putting in some utilities. So the natural utilities of any organization is like your accounting. Right. So I have products like an invoices contracts. I have payable ERCs where you can pay an ERC token, and it will proportionally split out that payment to whoever owns tokens. So you can use that for royalty payments or dividends, things like that. I have, ICO, like fundraising type contracts, and metered payment, like time metered payment contracts. So say for payrolls and stuff like that, you can forward commit your entire payroll for the month, right? And your employees or whoever you're paying, they can only withdraw the amount due to them up to that moment, right? Up to a block time resolution. If your employee does a runner, the owner of this contract can then actually change that payment, right? Stop it. They get refunded what hasn't been claimed, but the employee still gets to claim up to that moment. And on top of that is really what is quite a hard problem, and that's the governance layer, right? So this is, there's a whole white paper I've got about this, which I haven't published, and it needs to be rewritten because I wrote it a few years ago, and the whole project's moved on quite a bit. But in what I call my Ethenian DAO, we have members and we have matters, and members vote on matters, and it's a liquid democratic organisation. So then you can have, a fully governed, decentralised organisation. So this is an example of what I've got. I haven't got the governance layer on this. Just let me get it up and running. So I've just got this running on my private chain. We have up here, this is just a test front end. One of the biggest problems I run into is that I'm not a front end designer. Just trying to install Node and things like that. Node being a centralized system, Git now being a centralized, well, GitHub was always a decentralized system, but it's now owned by Microsoft. Like, I have great fears about Microsoft actually capturing the whole OSS market, which I think is really dangerous. Like, we now have browser imports, which are ubiquitous. We have IP package manager, right? Which we can start building up these all our dependencies. We can start throwing them in this distributed package management. But our whole community is still using Node. It's like, to me, that's just legacy now. We don't need servers to run our web pages. We've got, we can just do browser front ends, just pulling straight off IPFS or Swarm whenever it comes. But yeah, that's where my frustration's been. So I actually ended up having to write my own very short and sweet reactive template library. That's like, in 200 lines of code. It does all my reaction, it does all my template insertion and rendering. It has no dependencies, it's written in ES6. Anyway, so, but as I said, I'm not a designer. This is ugly as hell as far as UX goes.
80s retro is back in fashion.
80s retro, so obviously, well, you're just totally into the pixel art. So here's an example of my payable ERC20. We can see that it's already got a balance of 50, of which this account up here, he can see that he can withdraw 10 ETH of that. So he might withdraw all there. But you can see he's also got 20 tokens, he's got 10 ETH. Because this is a value handling token, like an ETH handling token, we don't want to lose that by people losing their keys or just simply forgetting that they're on this contract. Right? Otherwise, any payments that come to there, a proportion is lost. So you don't want to bleed your ETH into the furnace. So I actually have this function on here that tokens can be orphaned after, say, 3 years. And so someone has to interact with their account, or at least touch their account, and just sort of snapshot where they're at, just so, right. And if they don't, if that 3 years expires, anyone can come along and actually claim those tokens and any ether value that's actually against those tokens. If it's the owner themselves that hasn't interacted for 3 years or so, and you claim their tokens, you also claim ownership of the contract. And then we have, basic transfer functions, transfer from, approve, your basic ERC stuff. And here's my panel for managing, like for all the events, event logs. I'll just quickly show you, if people like looking at code, I'll show you an example of what a template is. So in, like, I call my framework, my front-end framework Tilix. It uses a candle analogy where you've got wax, you've got a wick. Oh, sorry, you've got wax, a wick, and a flame. No, sorry. Wax, flame, and sparks. So wax is your HTML. This is an ES6 string template literal. Right. Normally a template literal renders any expressions at assignment time. Right. That's problematic, and it limits our rendering ability to like our liveness or our reactiveness, because once it's rendered to a variable, then you can't change it again. So I use a little micro language where I sort of flip tokens around, and I have function insertion. So, and your functions insert, sub panels like sub templates and stuff like that. So that's an example of what your template literal looks like. This reg-base.advanced, that's another template that gets inserted, and insert another template there, insert a template there. Then we have our reactive data. Our reactive data is wrapped in a proxy, and the proxy handler, it has a setter whereby if it detects anything in that object being set, it will simply just go and re-render the HTML. And below that, we have the event handlers. Right, and we can, once it's rendered, it'll go through and it'll attach, it'll CSS select the elements, attach the event handler to it, and that's your page done. So, I might wrap it up there.
Maybe Q&A.
Oh yeah, Q&A, like, yeah. This is not secure, I should say. Like, it's only for testing. I'm really reluctant to actually put it up on GitHub even in this state, mainly because our entire render function comes down to this line. Which is essentially running eval across a template literal string. This line will recursively insert all your reactive data, all your templates, and then I'm using function. It's a little bit more sandboxed than eval, but I'm still yet to find a stronger sandbox for it. But yeah, like, trying to develop front end when you're not a front end developer on Web3 JS, which has got its problems.